So today we'll mostly talk about the Abaqus update. So it will have the Abaqus CAE updates. We'll talk about nonlinear mechanics, contact enhancement, and others. And then we'll open up for Q&A. It can be anything related to Abaqus or our services, and we'll also like to follow up with you later on. If you have any question, feel free to reach us out after the webinar. So regarding the company, so let me. Yeah, so we are a value solution partner for Dassault, and it's I mean I think all of you know who Dassault is, and they have been a leading provider for software solutions in the especially in the technology domain, and they started with CATIA, then gradually Abaqus was part of their solution. And now they have moved into PLM, and there are a lot of success stories about their solutions. So what, as VIAS we do, we are a leading simulation solution provider. We started in 2015. We have grown significantly since then, mostly focusing on Simulia is still our core strength here, but we also have added expertise around CATIA and other PLM solutions. We have give me 1 second. So we have also acquired IDEX solution, which has been leading PLM implementation since 1996. And they have a lot of experience in that domain. And also we have been collaborating with XLM solutions. So these are our 2018 update. So moving into 2019, we are becoming stronger to provide our clients the best value they wish for. So this is what we see us as a value provider. So we do engineering consulting. We provide software sales support and pre-sales and post-sales training, both in industry training as well as customized and out-of-the-box training. And we also help with automation and customization. So our team consists of mechanical, civil, and other engineers. From the simulation side, I'll mostly concentrate on the simulation side of things for this. And they have various different backgrounds like optimization, reliability, numerical techniques, solid mechanics, fluid mechanics, and all. We do bring our engineering consulting experience even for our software client, where we just don't sell the product. We try to look at their problem, understand their problem, and try to put it on the software solution space and see what's best for them. So if you have any question regarding your software needs or training needs or engineering consulting, do let us know. I'm trying to, there are more details to it. I'm trying to rush through it and get to the main interest for today. So this is a little bit on the digital transformation that Dassault is bringing using 3D experience. So there are many different aspects of it. One is social and collaborative apps. This is more of an apps and role-based platform. And then 3D modeling, simulation apps. So 3D modeling will be more on the CATIA side and all. And then the simulation apps is where we are talking about today. So Abaqus is part of the simulation app in 3D experience. And you also have the information intelligence app where you can analyze data, and also you can do a lot of like process composer and all. It's there those who are familiar with eyesight, so that's part of that eyesight experience. And what it gives is the real-time experience based on the physics. So you bring in the physics, it's more lifelike simulation, and the fidelity of the simulation is there. But it also helps with you collaborating among your teams, and also keeping your data at one place. These are our technical capabilities. We have experience in component design and validation using simulation. Whenever you are using simulation, validation is a big part of it. So we do have a lot of experience in helping client with coming up with a validation program, as well as sometimes we also help them with developing a test program that will validate certain properties or parameters in their model. We have experience around fracture mechanics, damage mechanics, and all. Optimization and reliability, structural analysis and vibration. We have capability around electromagnetic simulation as well, and also we do a lot of multi-physics, coupled fluid structure interaction, composite modeling and analysis. So simulation automation is something also we we do quite a bit. So if you have any repeated task, or if you want to make something like more of an input tech where the most of the difficult task is done on the background, so we provide those kind of services. We'll come up with the automation script for you and provide you for a service. And we also do digital mock-up, system engineering, including time mola and all. There are many various solutions. We can talk later on if you have any question. So I will that's pretty much with our value proposition. Sorry, the slides are moving a little slower. I'll probably skip this. So we are there to help you. We have a very good technical team with technical excellence and innovation. We have multiple domain experience, which we can think out of the box, and we have a very dedicated team, customer first focus. So if you have any need, believe we should be able to help you out. We also provide a lot of training. We have the training room here in Houston. We also provide on-site training and training at many other locations. Of course, we need a quorum of students, generally 2 to 3 students around. We can go and have, or you can have it at your place if you want to train your group over there. So we do provide both customized training out of Toolbox as well as industry-focused trainings. With that, I will give the slides, give the role back to Shri, and he will go over the Abaqus 2019 update. And as I mentioned, end of the day, if you have any question about the update, or in general any queries regarding your simulation need or PLM need, do let us know. We'll have our experts give you the answer as much as possible. Thank you. Shri, do you want to take over?
Hi, everyone. Hello, everyone. I hope you can hear me well. Sorry, I was.
It got muted for some reason. Can you speak from the beginning again? I'll mute myself.
Yeah, I think now you can hear me, right?
Yes, now we can hear you.
Okay. Yeah, sorry about that. So yeah, let's dive deep straight away into the Abaqus CAE 2019 updates. This is part of the overall Abaqus updates. This is one particular topic on the GUI part. Let's go ahead. Okay, so this is more of the model building aspect. If you have any part instance you need to translate or rotate in the assembly module, the current scenario would be you have to pick 2 points, or you define the 2 points by coordinates. But now the enhancement will include, you can actually pick a vector like a coordinate system axis or a datum axis or any straight geometry edge itself, and then specify a certain distance about which it will move the translate, or in the case of rotation, it will rotate about that axis. So it's a significant enhancement where you don't have to know the particular coordinates of a point or picking it from the predefined points by CAE, but now you can actually have more of a model based, which is like a geometry edge, or you define more of a existing coordinate system axis or datum axis. So that's a big enhancement in that in the modeling feature. The next one is about flattened input file support for model instances. You may know that in the assembly module, where you can have instances either from the parts that you have built in within that model, or you can actually import the instances from other models that you already have in the your file. So you can actually, in this case, for example, here what they show at the dialog box is you're importing a specific model instance from model 1, and on what happens is you couldn't create a flattened input file from this version of the model. Like once you import a model instance into the current model, you couldn't create a flattened input file from that. That restriction has been removed in Abaqus 2019, which is very important for substructure workflows, which usually work with only a flattened input file. So that's a significant enhancement. And they also say that CAE respects the user-defined node or element numbers as much as possible. And of course, the renumbering happens whenever needed. And the way to activate the flattened input file, you may recall, is on the model in the Abaqus GUI part. On the model, if you click right click, and you can choose the edit attributes, and then you can choose the do not use parts and assemblies in input files. You can check that box. It will create a flattened input file for you. We also started supporting, giving support to the CAXA and SAXA elements in GUI. That's basically axis-symmetric elements, but with asymmetric deformation. It supports both the first and second order continuum and shell elements. You can specify 1 to 4 Fourier modes, and extra nodes are generated in the input file only. You don't see it in the CAE part. Non-default node number offset can also be specified if you want to have that. Nodes due to Fourier modes do not exist in CAE, so basically you don't see them, so they cannot be picked up. But in the input file, they're created when it's written. Abaqus doesn't support element-based surfaces on CAXA or SXA elements. So what will happen is, even if you define it in CAE, they will just not be written in the input file. Pressure loads will be automatically be applied using deload instead of DS load. So usually for a pressure load, DS load is automatically created, but in this case, they use deload, which is an element-based load description. This one is about fluid inflator interactions and properties. So it's mostly used in airbag systems and so on. If you have a fluid inflator, you need to define which was not earlier available in the GUI part and earlier releases. Now it's been activated in Abaqus 2019 release. The way to define that would be to create an interaction. So you go to interaction module, just like any other thing, like a contact or tie, and you create an interaction there, and you have an option to choose fluid inflator property now. Once you have to associate the fluid inflator with a fluid cavity interaction, and once you do that, it'll actually open up a set of dialog boxes in sequential way once you keep progressing. So you have to create the interaction property fluid inflator, and then it'll ask you to fill in those dialog boxes that you see on the right bottom, edit interaction property, and once you are done with that, you basically define the fluid inflator in GUI. So fluid inflator property defines basically mass flow rate, temperature, inflation time data, and mixture of gases entering the fluid cavity. So within the cavity, you can have a mixture of different entities. Those can be defined with different interaction properties as seen in the bottom right dialog box. There's some optimization enhancements. This is related to Abaqus and Tosca coupling in a way. Support for overhang restriction for topology optimization. So just in case if you have some kind of a structure in the, I don't know if you can see my mouse, but if you see in the middle here, there are red color support structures. These are required for because of the additive manufacturing constraints, because of the model geometry specifically. So we have to have the supports also included in the modeling. But with the new enhancement where you can define some overhanging constraint, it'll be that constraint, that necessity to define support structures is removed. So for example, here in the dialog box, you can see by geometric restriction, you can define an overhang angle. That's basically defined by the red line here with an angle alpha. So based on that, you can actually remove the support structures and have a model free of the support structures. That will save some time. There's also sensitivity-based shape optimization. Shape optimization didn't have the sensitivity or studies option with Abaqus and Tosca, but now that has been included. The dialog box here, you can see that earlier it used to be only condition-based optimization, but now we have an extra option of using a general optimization sensitivity-based algorithm too for shape. It was available for other optimization aspects like the topology, the beam sizing and all that. But I think for shape, this is the first time they introduced in 2019. So the available options for optimization parameters include like the regular ones, design responses, objective functions, constraints, and they'll vary according to the algorithm that you select, either the condition-based or general optimization. You also have this one, like the way to define that would be use Abaqus sensitivities when possible. This particular one will be available in the dialog box. And actually what it does is internally, it will activate the sense calc mode, which is like a parameter for Tosca, into automatic. Otherwise, it will again go back to the original one, which is like the sensitivities with sequential run mode in Tosca. This is available for all task types, topology, shape, bead, and sizing. And also the new enhancement has that you can in fact use IGS surfaces formats for the surfaces. So in the optimization task, the earlier options were only the Abaqus input file or STL. Now the new format has been added is IGS format. So the element output with the position average at nodes, when you have this keyword, which is actually the input file format, this one would write the output with average at nodes. But that was not available to be visualized in the ODB when you open it in the CAE. It was more like an output that could be written, I think, to the DAT file. But now they actually included that as a field output. So you can see that in the CAE itself. All operations related to a nodal field supported, like contour, symbol plots, probe, etc. And then these are the bunch of operations that can be done using that for that particular output. I will skip the details because we have so many other topics to cover. But basically, most of the regular operations that you usually do with contour plot or field output, you can do that same with this particular one too. Invariant computations for complex frequency results. So if you have a complex frequency in your model, in your solution, the three complex envelope options have been added, which is basically min, max, and max absolute. The way they work is the new options like of the combined value of the real and imaginary portion of the result by varying the angle from 0 to 360 degrees. These envelope methods are great alternative to visualize the complex form of stress invariants. That would be very useful there. There's a new variable called B radius that's available for output. When you request it through, again, I don't think it's available as a model output request. The GUI output request. You have to go through the input file or the keyword. Once you request that particular output called B radius, this is you can actually check. You can see it as a contour plot. So you will basically see the radius of the beam as contour plot. So that will help you to generally see what's the spatial distribution of your beam radius across the whole model. This is very useful for lattice beam optimization techniques, where you would like to see what kind of beam radii are being given overall in the whole model. And the way to activate the beam radius itself in CAE visualization module would be to go through this particular dialog box. It's render beam profiles. You get it through one of the menu options. There are other enhancements. I will just briefly go over the particular topic without going into details. We can export now CAE assemblies to spatial ASAT format, which is useful for 3D experience. We can also capture all parts and assembly positioning in that, and supports model instances also besides the part instances. Support selection of multiple frames at once in field output reports. This is a new one. Basically, you can have multiple frames written together into the field output reports like a text format. You can also select active steps of frames that are included to be included in the report. So if you want only some specific frames that are active in the model in your visualization module at that point of time, you can just write only those active steps of frames into the report too. It also works with annotated or CSV formats, which can be used in Excel sheets for further processing. There's also a reverse contour plot legend that basically has minimum on the top and maximum in the bottom. That's useful for some of the processes that you might want to have. There's also scripting API enhancements. So basically retrieve a cross-sectional area defined by a free body cut. There's also get exterior element faces of a solid element sequences. So if you have some kind of a sequence of elements, you can actually extract only the exterior element faces that are facing the outside region. Also, you can also get exterior element edges of shell or 2D element sequences. With that, the GUI updates I think are over, and let's move on to the next one, which is the nonlinear mechanics updates. This is more related to the solver part in a way. Additive manufacturing updates. This is a new enhancement we have for additive manufacturing. Output the displacement or rotation at a node from the time it becomes active. We also have provide better agreement with experimental results in the case when inactive elements follow the movement of the active elements because of this enhancement. Both history and field are supported in this case. So for example, here in the picture, they show displacements in a plate. For example, follow deformation equal to no and follow deformation equal to yes. You can see a significant change in results. The next one is a convergence improvement of heat transfer analysis. Some of the heat transfer analysis run pretty slow. It's better to have in the performance sake and also in the convergence aspect too. So those have been enhanced in this particular release. both for transient and steady state when linear elements and temperature dependent conductivity are used. Improvement was achieved by consistent evaluation of conductivity at the integration point. In some cases, heat transfer analysis that previously failed to converge actually now begin to complete successfully. So that's a big improvement. There's also an improvement implemented for specifically the brick elements, the hexahedral elements. And the previous behavior, you can restore it if you want to by using that particular keyword, section controls, HT integration equal to old. Just in case if you want to have old results to be used for something for your current analysis also in a way. The size of the event series data is no longer limited to 2 GB. We can actually now go beyond that. You can now define event series with over 420 million events. Enhancement is available only for event series defined in the sim file, which is basically like a file parameter on star event series. So you have to use that to activate that sim file. It's available for pure heat transfer analysis in Abaqus standard, both field and history output. Then there are a bunch of field output variables. These are the ones that have been introduced in the Abaqus 2019 update. It's EHMD flux, which is basically element internal heat energy due to non-uniform moving flux. There's also another variable, element internal heat energy density due to non-uniform moving flux. And then there is whole model heat energy transfer energy due to non-uniform moving flux. So this is basically with respect to heat transfer, and there's the element energy, internal energy, heat energy, and density, and whole model and heat transfer energy. Then moving on to the next one, which is fracture mechanics. There's a linear elastic fatigue crack growth under mixed mode conditions. There's one update on that, which basically improves the performance, both the general and simplified approaches. It allows for change of contact conditions within a loading cycle. Then again, it accounts for a large geometric nonlinearity, and also it accounts for mixed mode fatigue loading. So these are the enhancements with regard to linear elastic fatigue crack growth under mixed mode conditions. The next one is for XFEM for 3D non-planar cracks, smoothing the predicted crack direction along the crack front. Include the contributions from the normal of not only the elements ahead of the crack, but also the elements directly behind the crack front. So that was not available earlier, and that has been introduced in the new release. Improved performance and convergence with multiple node release. By default, only one row of nodes are allowed to fracture ahead of the crack front within one increment. But now they have relaxed that, and now we can see multiple nodes that can can undergo fracture without really affecting the performance. Symmetric cohesive elements, there's an update on that too. Symmetric plane can be chosen as any plane which is perpendicular to one of the global coordinate axes. Symmetric deformation of cohesive elements will be automatically enforced, and the user doesn't need to apply any symmetric constraints or boundary conditions. So there's less work required from the user to define those. With regard to specifically to elements, there have been two sets of elements that have been introduced in Abaqus 2019. One set is poroelastic acoustic biot elements. These are like a couple for structural and acoustic analysis. So they actually nomenclature C3D8A, where structural is C3D8 and A stands for the acoustic. And you have other shapes like multiple shapes like brick, wedge, and tetrahedron. The same shape functions are used for both the displacements and pressures, which are the variables that will be solved for. The other set of elements are the new shear panel element, shear 4 for Abaqus standard. These are mostly used in aircraft wing and fuselage structures. It will be very useful there. They are intended to model the response of a buckle plate. Shear panel elements carry only shear forces applied to their edges. There are 4 noded elements with 3 displacement degrees of freedom at each node, and only elastic material can be applied for these materials, for these elements. Excuse me. So as I mentioned earlier, the B radius was the output variable. You can actually now define that for the beam elements. It's supported in Abaqus CAE for the contour plot output display, but it cannot be used for definition or request of the output itself. For that, you need to use the input file, which is what they said as in star element output, you add B radius in the data lines itself. And to display the output, you have to again render the beam profiles in the visualization module of Abaqus CAE once you open the ODB with the beam elements in the model. There's also element solution dependent variables output that's given, as an output variable, ESDV. In Abaqus standard, one can now access and update ESDVs in user subroutines and allocate spaces for that. These are specifically used in additive manufacturing when you want to group a bunch of elements together based on some specific output of those or values of those these variables. It's used to define ESDV to control element deletion and also user-defined output labels and descriptions. A new type equal to ESDV of star initial conditions is introduced. It requests outputs of ESDVs as new output variables, ESDV and ESDVN, where n stands for the number of variables. Low density foam, this is a specific material enhancement now. The model is already available in Abaqus Explicit, but I think it's been introduced in standard now. The model is intended for highly compressible elastomeric foams. Import is fully supported, but there are some limitations. It's only applicable for quasi-static response. For quasi-static response, the strain rate dependence is ignored, and tension cutoff and failure are not supported. They're ignored if included in the definition. There's also a new output variable for rock mechanics effective stress, output variable SROC for rock mechanics effective stress. SROC is used for checking damage initiation, not for describing constitutive model of porous media. So it's only for damage initiation, and it's an output variable. Enhancements to superelastic materials, a modified formulation for superelastic material is introduced. This is basically like inbuilt materials in Abaqus, like nitinol, for example, which is used in stent analysis. It improves. They have actually improved the functionality, import functionality between Abaqus solvers, and also improved the convergence and performance of the material model itself. A new keyword has been added in Abaqus. This is more of a section definition, star transverse shear. It allows users to define material transverse shear moduli for computing transverse shear stiffness of shells and beams. It eliminates the needs, which was the earlier one, to define transverse shear stiffness as part of the section definition. But now we can have that as a material definition. It was convenient to use users to compute transverse shear stiffness when a shell section has spatially varying thickness or a shell section is made of composites. Now it's defined as a sub-option of star material transverse shear, which is type equal to isotropic, orthotropic, anisotropic, and dependencies are based on the field. There's also material failure and element deletion available for concrete damage plasticity. Material failure criteria can be defined, and element deletion is allowed for concrete damage plasticity. Pardon me for the typo there, it's concrete. A new keyword, star concrete failure, is introduced. Concrete failure type equal to strain, default, or displacement. Again, dependencies on any field variable. You can define the strain or the displacement, tensile or compressive, and also the damage variable. Again, based on field dependence if you have that. Output enhancements for traction separation response. In Abaqus Explicit, two new output variables are introduced. Basically, NEEQ, which is equivalent nominal strain, which is again given as a formula there. It's a function of normal strain and shear and tangential. Effective separation for basically the separation between the two surfaces which are joined by these cohesive elements is defined by that formula, which is the effective strain times the T naught, the distance between the two. So the distance between the two surfaces, which is given by the cohesive element thickness. The NEQR is equivalent nominal strain rate. It's epsilon dot E effective. Basically, this is a strain rate. It's again just the same way as epsilon effective, but that's dependence on time. Homogenization for viscoelastic composites, that's been introduced in this new release. Damage and failure, there's a micro level damage. So basically you can introduce a damage at a micro level, and the macro level damage also will be computed with the user defined damage criteria. That's basically the U damage MF, that's the user subroutine. Utility user subroutine to get state of each constituent. You can get it from the utility user subroutine. And then you have the injection molding workflow. That's basically the example they're talking about. So define a fiber dispersion through distributions and then read fiber orientations from a same file and then mapping capability. These are also the enhancements that has been introduced, but these are only for the limited access. Moving on to the next topic, it's about contact. By and large, contact has been seeing improvements over a period of last few years, especially by introduction of general contact in Abaqus standard. So it has been seeing like various formulations and even the different dimensions like Axi-symmetric 2D models, 3D models, and so on. So this is one more step towards that. So basically enable use of explicit general contact. Now this is for explicit, previously allowed for Abaqus standard. So Axi-symmetric and 2D models, they were you could use the general contact for them in standard, but now explicit also has introduced that. Keyword and CA interface same as 3D, fully functional, robust, and there's a good parallel scaling also. Some of the examples are being shown here in animation. I will skip the details part of it. This is regard to Abaqus standard. It had a limitation that you couldn't use analytical rigid surfaces for general contact. Now that has been relaxed, but that was available in explicit, by the way. So again, as I was saying earlier, these enhancements have been introduced in standard over a period of last few years. They have started with surface to surface, then they had edge to edge added, edge to surface, vertex to surface, and so on. And some of them had new features added because of this, and because of the analytical rigid surface. That's a big enhancement because I think that was one of the limitations for general contact in Abaqus standard that's been addressed in this release. Again, this is an example where they're trying to show that you can actually see the output of what are the surfaces that are getting into general contact definition. Once you open the ODB in a visualization module of Abaqus CAE, all you have to do is go to the create display group and check the internal sets for the surfaces and see, and it'll highlight you what are the general contact surfaces or faces that are in coming contact. So they are also saying that if you have symmetry boundary conditions specified on the sliver of a deformable blank, that's being shown here. Internal surface for punch is highlighted in red. So all those details of a general contact, what are the master and slave in a way, that's being shown in the, you can see that in the create display group from internal sets of the surfaces. Now this is moving on to the next one, is a threaded interface approximation, especially for bolt interaction with the other components in the system. Cylindrical mesh threads are defeatured. There's a small sliding contact, normal adjusted with consideration of reference thread geometry. And then you have you can uniformly it uniformly corresponds to same thread face, top or bottom. This is a pre-existing capability, but there were some issues with that, and they fixed it as a bug. So what you see as the contact normal wasn't defined properly in some cases. They actually addressed that, and they can also define now a consistent positive thread angle in the GUI itself. There are new options that have been added. The small sliding contact normal locally associated with top or bottom thread face, which is more realistic. And there's also you could actually have both threaded sides, like right or left-handed threads now in the new enhancement. The next one is a thermal and electrical coupling. If you have, you can use general contact with the following procedures: pure heat transfer, also, and coupled thermal electrical. Earlier that was not available for these two particular procedures. Allows the consistent use of general contact across sequential thermal stress analysis. So for example, now because you can use the general contact in both the thermal and structural analysis, it's somewhat seamless. Otherwise earlier you have to use the contact pair definition for the thermal procedures and then use regular general contact for stress analysis. So instead of having two different definitions, now you can have the same general contact definition for both analysis. So that's a kind of a enhancement in Abaqus standard for this release. There are two new contact output variables. One of them is the C edge active. It's basically a follow-up to dynamic feature edge criteria enhancement of Abaqus 2018 release. It enables contour plots of edge status current limitation. Basically, what they're saying is C edge at whatever the edges that are in current frame that are in contact, they will be activated and shown to you. So you know which particular edges are actually in contact at that instant. C-slip PL, which is basically a plastic contact slip represents plastic slip associated with exceeding critical friction stress. If you may recall, this is the plot that we are talking about from the documentation. This is the elastic slip condition, and then there's beyond that is the plastic slip. So what they're saying is, we can have the output of that as a particular variable called cslip_pl. There's a 1 and 2 directions for 3D component, 3D surface. There's also an equivalent plastic contact slip that's also been introduced. There's no output variable specifically for elastic slip, but once you have the total slip, C slip, and also you have the new variable now with the plastic contact slip, you can actually get that as a difference. There's also a new variable CI-CPS. This is a scalar output variable giving integral of contact pressure over the entire surface. The difference being between this one and CFN, which already exists, contact force normal output for the surface. It's basically in CFN, you take care of the normal direction. So when you have a cylindrical surface acted upon by external pressure P, suppose uniform pressure entirely, your CFN will almost come to 0 because of the symmetry conditions. Whereas CI-CPS would disregard the normal definition and basically just give you a total force. This was requested by some users, so that's been implemented in this release. For example, what they're talking about is consider an interference fit between concentric rings. You have uniform contact pressure because of the concentric rings, but ultimately the CFN output would be 0 because of the symmetry, whereas CI-CPS would show a non-zero value for that. There's also a movement due to shell offset and the normal force that's acting on it. So when you have in the previous behavior, you have contact normal force that acts through the nodal location with no consideration of shell offset. But now because that has been enhanced so that you can actually introduce the effect of the shell offset and the movement because of that. So that led to the previous behavior led to non-physical bending for cases with shell offset, but that has been removed with the new enhancement now. It can be accessed via contact controls assignment, rotational terms equal to structural. This is the picture. It says edge view of the edge view of the shells. So, for example, you have this with the shell offset, but the slave, and basically you would see the results may not be meaningful in this kind of a scenario in the previous one, but now the current scenario it works better. There's also another enhancement about shell thickness itself. This is nothing to do with offset, it's just the thickness of the shell with the tangential force. So earlier behavior used to lead to misleading results again. So pre-existing behavior, we used to generate the force couples on the slave nodes to cancel moment associated with the tangential force that times the net surface thickness. So if you have the tangential force acting at the interface between these two shell elements, the offset or basically the moment because of the couple or the moment that a moment arm from the thickness half of the thickness of the slave, that's basically that's what has been mentioned here, and that was introduced here as a couple, as a force couple. You can see that ft times one particular fraction here, the negative one, and ft times another particular fraction, the positive one. So that's basically the force couple that has been introduced by transferring the tangential force to the center of the slave. This was the previous behavior. With the new behavior, what they did is they actually independently take care of the shell and the master separately instead of just using only the shell thickness. So this leads to better accuracy in that matter. So basically, they actually transferring both of them independently. You can see that now the force couples actually come out for the master surface also, the master element too, differently from what has been given for the slave. Cohesive contact, this multifaceted effort across releases to improve the robustness and accuracy in cohesive contact, also increase the consistency with cohesive element behavior. Initial focus areas for Abaqus standard: reduce sensitivity to master and slave roles. So if you interchange them, they shouldn't play a big significant role at least. Offset point of contact from reference surfaces based on respective thickness contributions. Cohesive normal direction based on average of adjacent surface normal directions. The improved treatment of stiff permanent cohesive bonds. So make this an attractive alternative to surface-based tie constraints. So that would help in performance itself. Initial focus areas for Abaqus Explicit. This is specifically for Explicit. Avoid unstable behavior of cohesive contact and performance. I have seen previously very large models with cohesive contact definition and explicit. They used to take a lot of time. I hope the performance has been definitely improved with this particular feature. Deprecate old contact controls. There are some old contact control definitions that have been removed from, and they've been removed over, or at least there's an effort to be removed from previous releases, say 6.11. And some of these have been listed here: approach, automatic tolerances, friction onset, Lagrange multiplier, max CHP, per RMX, UER RMX. Without going to the details of each of these parameters, these are the ones that you might want to look for if you see any error. So the current release would give an error if you have these features for contact controls requested. But if you want to revert to only a warning state, you can do that by just saying start diagnostics old contact controls equal to warning. So it will set the error into a warning for you. Initial contact stress. So suppose you have two bodies coming into contact and they have initial stress defined for those bodies. Currently what, or at least up to our Abaqus 2019, the initial contact stress was seen as 0, but that used to lead to misleading results. So now with the enhancement, what they did is you can actually define an initial contact stress between the two bodies also when they are having some initial stress defined for between them. So it's useful for geomechanics and other workflows. And the way to define that would be, okay, I guess this slide doesn't have details of how to define them, but I think you can define them by just defining the initial conditions for the contact stress. Okay, this is the example where initial state, you basically confining the two bodies and you actually define some initial stress. That's basically showing you the stress at the t equal to 0, that's initially. And once you actually see the final state, you see the previous analysis, previous releases, they used to give misleading results for the stress. There was a loss of 11% in them. But if you see the current, for the current release with the enhancement, you see the stresses are actually preserved properly because you have defined the initial contact stress between the two bodies correctly in that case. So to summarize, contact development remains a very active process. They want to fill in the missing features in general contact, also generally improve the usability, accuracy, and performance. They also improve the cohesive contact and many bug fixes too. And there was a bunch of output variables and some particular shell thickness and shell offset updates with respect to contact forces between the shell elements. There's old contact controls that have been deprecated and initial contact stress has been introduced in this particular release. Next, moving on to a new topic, Abaqus multi-grid iterative solver updates. So by and large, generally people use direct solver as opposed to the iterative solver, but it's very helpful for large scale simulations to have iterative solver working well. So all major customers demand for solving larger and larger problems. Say someone solving in 2005 with say 1 million degrees of freedom, maybe currently running with 200 million degrees of freedom just because the computational resources are available. But the performance also has to catch up from the Abaqus solver side. So that's basically what the effort has been. For high fidelity and accuracy, you may want the same model, which may be of a small size, but you want to have a very refined mesh just for sake of accuracy and high fidelity. Or otherwise, you could just have a bunch of small models, but it becomes a very large assembly itself, like I say for a full car model itself. So when you have a lot of components, again, you have a lot of degrees of freedom that need to be solved for. So in either case, a good solver with a very high performance would be very helpful. So challenges are the number of flops for direct sparse solver. It increases non-linearly with number of degrees of freedom. So you may start with a very small number for 1 million degrees of freedom, but with say a large number of degrees of freedom, the scaling will be non-linear and it affects the performance. So the memory requirement is another issue with that, just not the performance. So iterative solver would be helpful in that case. It uses relatively less memory than the direct solver. It's generally faster. It's a scalable performance. So that means it's a linear thing. If you your performance and memory requirement also will go linearly with the in case of iterative solver. Relatively robust for well-conditioned problems too. The way to define that, it'll be in the keyword usage. Will be star step solver equal to iterative. There are a bunch of Abaqus environment variables that you can use, memory 90% and MPI run, where if you want to run it on multiple nodes. Default convergence tolerance and maximum number of iterations can also be specified. The default are 1e minus 6 and 500 maximum number of iterations per solver pass. You can change the default values. Keyword need to change for each is solver controls, and that with the data lines 1e minus convergence tolerance and maximum number of iterations. This is just showing you an example how things have sped up or became faster with iterative solver over the from the previous release, and also the memory reduction too. I think I'll just generally skip the details about it because it just shows that the high iterative solver is doing much better. With that, I'll go on to the new topic here. It's linear dynamics updates. So these are a bunch of updates that have been introduced in 2019. Although it says 2018 on the slide, it's basically fixed back. So whatever has been introduced in that 2018 after the general release, that's been mentioned there. So these are like a cumulative one for 2019 as an update. There are a bunch of improvements that's been listed here. We will talk about a few of them, and if you have more questions, or you can always come back to us later for any of these particular updates that you may be interested in. Performance of the static analysis with multiple load cases. The following improvements are implemented for linear perturbation static analysis with multiple load cases. So if you have multiple load cases in a linear perturbation static analysis, one thing that used to be bad about it was basically the performance. It used to be much slow. That has been improved now. Specifically because of writing the solution into the internal Abaqus database, that has been made faster. There's also substantial computational performance gain is achieved for analysis with multiple load cases with a relatively small number of concentrated loads. There's also improved symmetric memory parallel scaling for linear perturbation static analysis with inertia relief loading. This is specifically for inertia relief procedures. Enabled linear perturbation static analysis with inertia relief loading for simulation models defined using sparse matrices to represent the stiffness and the mass of the model or a part of the model. There's also improved robustness of the distributed memory parallel so that you are running actually on multiple nodes. Execution of linear perturbation static analysis with multiple load cases for extremely large finite element models. So the overall takeaway is that the performance of linear perturbation static analysis with multiple load cases has been improved over the previous release. There's also a new functionality that has been introduced. It's called missing mass method for response spectrum analysis specifically. Using the missing mass method is recommended by the ASCE standard. It's a code for safety related issues on nuclear structures. Use the missing mass method to augment the missing inertia in the dynamic response when the number of eigenmodes included in the superposition does not sufficiently quantify the total mass of the structure itself. So usually you choose a particular set of eigenmodes, and any other higher frequency modes you tend to ignore. But any losses because of the contribution from those frequency modes, you can actually include that now with something called as a missing mass method feature. The way to activate that would be keyword interface is star response spectrum, comma sim equal to CQC, rigid response equal to a particular method called here Gupta, and you just have to add the parameter missing mass method. There's an example given here. It shows the comparison between having that missing mass method activated and not activated. For example, the highlighted one here in the red color, it shows that at the 3 number of modes, which is like a much reduced number of modes, the accuracy with the missing mass method active is much better. And now we also have substructure output results that can be written to sim file. If you recall, sim file is useful for accessing the for HPVs in 3D experience. You can actually open that file format in the 3D experience and visualize your results, which was earlier not available for substructure. Now it's available. Basically, you will activate it through results ODB format equal to sim. I'm sorry, results format equal to sim. This functionality is first, so the next one is MPC improvement itself. It's removed limitation due to number of load cases for large models in the MPC recovery code. So if you had a very large number of load cases and large number degrees of freedom in the model itself, the MPC had, and also MPCs in the model, of course, there was some kind of restriction there. Now it used to actually abort with the error message exceeding number of integers allowed. So when running static or direct steady state dynamic analysis with multiple load cases for large models, but now that restriction has been removed. So basically the performance has been improved, and also memory usage itself for the static perturbation analysis and also for direct steady state dynamic analysis, both the single core, single node and multiple node analysis, compute node analysis. It is possible now to solve problems those that couldn't be solved before. For example, they are talking about a body in white car model which had a very large number of degrees of freedom, 36 million. There are 132 load cases itself and many thousands of tie definitions, and that couldn't be solved before in the previous releases, but now that can be solved. There's also improved end fork. There's nodal forces, sorry, output variable. Formulation is available in direct steady state dynamic analysis. In all, without going to full details of that, what I would like to state is in the earlier releases, end fork output would compute for a direct steady state analysis only the displacement contribution, but now both the inertia and damping effects are included in the end fork output. What the details say is that they're including both the hourglass and the regular deformation modes of the element. But the underlying formulation used to be only the displacement contribution, but now we have both the inertia and damping terms also for steady state dynamic analysis. And then the following enhancements are available for shell thickness defined as part of the element connectivity can be translated from Nastran. These are about translation from Nastran. Distribution is now used. So earlier when you used to have shell thickness varying across different elements, it used to be a problem. But now star distribution is automatically created in Abaqus when translating from Nastran. Significant speed up is achieved for the translation of very large models that have distributed couplings and or concentrated mass elements. So if you have a lot of those features in the model from Nastran, now the translation is much faster. For example, 26 million degrees of freedom body in white model, which was mentioned earlier, with 200K con M2 point mass elements, that's from Nastran, and 100K RBE3 elements, which is basically distributing couplings equivalent in Nastran. Now the translation time has been reduced from 2.5 hours to 10 minutes. So that's a very significant improvement in performance. There's also substructure recovery, performance, and usability. So you can recover the results in a substructure once you have used it in a model. Basically, first thing is an improved performance itself, the writing results to the output database, and also principal stress and strain calculation. And we also added command line arguments to customize the output, like min frame value, max frame value, and so on. Added command line arguments to select a particular time or frequency interval for recovery. And we also added calculation of the absolute max principal stress. So here the way to activate that would be results format equal to ODB and position equal to average at nodes. Implemented recovery results for the free substructure eigenmodes too. Energy and energy flow calculation, direct SSD, direct steady state dynamics procedure enhancements, energy output for multiple load cases. There are many new energy output variables. There's also energy and power flow calculation. Current limitations were porous elastic elements, acoustic elements with perfectly matched layers, infinite solid elements. Energy variables for quiet boundaries are computed only for first load case only. Radiated acoustic energy or power is not supported in DMP mode. I think this is the last topic. With this, we'll we'll switch to the Q&A. So basically, the significant multi-year effort to compute adjoint design sensitivities inside of Abaqus standard. Drive combined Abaqus Tosca design optimization workflows, both CAE and 3DX based. Output of sensitivities from a standalone Abaqus standard analysis, which I briefly mentioned earlier. It's also included in Abaqus documentation. Currently, we support topology, sizing, lattice shape, and bead sensitivities, which is basically the full scale. And their bead is currently only available in LA, but will be available as a GA from 2019 onwards. There are a bunch of more new features, but I think for lack of time, I will just skip them. But you will have this as available for your whenever you want to check this in. And also, if you have any questions, you can always come back to us. We will always help you out with the details of each of these topics too. So with that, I think I will just skip the rest of the slides, and thank you for your time. Let's move on to the Q&A session. I think if you have any questions, we can take them up.
Hi, thank you, Shri. Thanks a lot. Sorry, we are running a little bit late on the time, so we have a bunch of questions. We'll start going through it. Just one thing, Shri, can you go back to the previous slide?
Yes.
No, no, the next one.
Okay.
No, with our contact information.
Oh, this one?
Yeah, so we'll also share our contact information so you
Sure.
can email us or reach out to phone numbers, and we have our email IDs at the title slide. So we'll share everything that we have presented, including a recording of the webinar. So we'll now go through the questions and try to answer to the best of our knowledge. So Kanizi is going to read the question, or maybe I can read the question, and then you can answer.
Sure.
Okay. So first question is, are the AM enhancements part of the general Abaqus license?
Yeah, I would request even my colleague, even Subhadeep, to join this because he also has worked on these topics. Yeah, please, Subhadeep, could you please?
Let me unmute.
Hi, hello everyone. Yeah, so myself Subhadeep here from VIAS Corporation. So the AM enhancement is basically a particular thing which is available by default in the general Abaqus license, but the AM workflow is basically done through a plugin. So definitely all the enhancements are available in the general Abaqus license itself.
Okay. And then the next question is, this early part of the webinar, will a recording be made available? Yes, we'll make the recording link available to you. And generally we post it on YouTube and all, and you can also follow up on our LinkedIn company page, and we'll provide you all our contact information as well. And if you have any question, as she mentioned, some of the things we had to rush it through because of the time. This kind of more give you an exposure, but if there is any specific question, we'll be more than happy to talk to you and give you an answer. Okay. So next question, any changes, particularly in material card creation for forms using hyperelastic material model, using uniaxial test data and SDV? I'm interested in hyperelastic, hyperform, elastic plastic, and crushable forms.
Okay, so hyperelastic and elastic plastic card is remaining same. And for hyperform and crushable form, we have included that one in Abaqus standard, but regarding the card creation, there is no change. It is as usual.
Okay. Next question. So I'm wondering if there is new constitutive models for concrete in the new version of Abaqus. Also, I have the same question about the heat transfer, thermal mechanical loading, coupled analysis in Abaqus.
Okay, so in Abaqus, the concrete damage plasticity was introduced long before. So now in the recent version of Abaqus 2019, they have introduced the failure and element deletion behavior in the Abaqus explicit analysis. So that is basically useful if you are doing some kind of blast analysis or explicit analysis where you expect that the concrete material can fail. So the failure and the deletion criteria is added additionally. But in the heat transfer and mechanical loading, there is no such addition in the material model as such.
Okay, if I understand the question, sorry, so the question is about similar constitutive, basically damage model for mechanical, thermal mechanical loading, right?
Yeah.
So, okay, you are saying that's not.
Yeah, but there is no improvement on that one. Yeah.
Okay, yeah. Maybe you want to double check and let's get back one more time. Okay. Can we consider, I'm going to the next question, can we consider max principal stress contours as tensile stress, minimum principal stress as compressive stress, S12 as shear stress in 4-point bending test conducted on a 3-layered composite board used for load floors in cars?
I think I should probably get back to that question with more details, I think, to understand, in my opinion. Are there more?
No, this is more than an Abaqus question. It's about whether it's the correct representation of the stress field, right? So yeah, we'll get back to you on that. Okay. I think similar question. Is there any significant improvement in concrete modeling? So apart from that damage, I don't think there is modeling.
Yeah, that's right. Yep.
So next question, if there are any update on the Abaqus welding plugin with Abaqus 2019 or any potential influence on welding plugin from Abaqus 2019. So this one, as far as we know, it's so there is no update with 2019. So and the welding plugin is available, the old version of the welding plugin. AWI Abaqus welding interface in your partner, I mean basically community, Simulia community, if you have a login over there. And I believe there is no further update or improvement on that. Subhadeep, Sri, do you want to make any comment?
Yeah, so the last version of Abaqus welding interface was Abaqus 2017 HF5.
Yeah.
After that, there is no development has been introduced. So it is remaining as it is.
Yeah. So additive manufacturing update was mentioned in the presentation. Do you have a module for additive manufacturing in new Abaqus? I do not have it in my current version, which is 6.14. So if yes, is it integrated or separated in the new version?
Okay, so additive manufacturing is basically introduced in Abaqus by using a AM plugin. So if you're having the access to the AM plugin, then you can definitely have an example problem as well. But
Yeah.
we can share some example problem with you as well if you want.
Yeah, so you can send us an email to any of the emails mentioned here, and we'll get back to you on that. But it's, yeah, to answer your question, it should be in there. Okay, it's a general question. Will the slides be sent out after the webinar? Yes, we'll share a PDF, and also we post it on our social media outlets, LinkedIn and all, and our website as well. So you should be able to. And if you have, again, I'm repeating this probably, but any questions, this is not just a 45-minute engagement, so to get back to us. Okay. Okay, so same question about presentation, and also I'm skipping those, not reading back again. Okay, I'm wondering if there is a new constitutive. Okay, so basically, Subhadeep, can you repeat on the question about, I'm wondering if there is new constitutive models for concrete in new version. Probably there was a microphone problem or something. Also, I have the same question about the heat transfer, thermal mechanical loading coupled account. So maybe just you want to repeat what you said.
Yeah, so in the heat transfer and thermal stress analysis, there is no new constitutive model is introduced. But in the concrete damage and failure behavior, they have introduced the concrete failure and delete of the element recently in Abaqus 2019 version. So I think we have answered that question previously.
Yeah. So it was asked to repeat the answer again. So. Okay, so last, I think VIAS is planning to provide any advanced training on application of concrete damage plasticity model in near future. So this kind of advanced training, we generally don't like put it out as we are providing a training on a very specific topic, but you can contact us, and if we have adequate number of students, we can always, I mean, we have the capability to provide the training. But it's just because there are only few interested people. If they contact us, and then we generally conduct that. So this is open for all of you. If you need any particular training, and we also do a lot of customized training, so these are not out of the toolbox. So you have, and we see our queries coming from many people, and if there is a commonality, so we group them together and provide training on it on their specific needs. So please feel free to send us an email or contact us and ask whatever you want to get a training for, and we'll try to accommodate. Is there any other question? Okay, so there's another. What is the difference between? Okay, so this one. Sorry, there are two different windows. So material card is done.
So Arindam, there are a few questions in the Zoom webinar chat window.
Yes, that's what I'm reading right now. Okay. Are additional keywords needed to define initial contact stress, or is it handled automatically by star initial condition, comma type equals to stress?
It's actually handled automatically by star initial condition. So previously it used to create automatically the contact stress equal to 0. So now if you provide a initial condition equal to stress, it will establish a contact stress in the contacting location. So that basically improve the convergence behavior in a better way.
Okay. There are many questions repeating about the materials be available. Yes, we'll have it available. Okay. Does Abaqus 2019 additive manufacturing capabilities, particularly progressive element activation, allow for partial activation, volume fraction between 0 and 1?
Yeah, it does allow that one. So the subroutine is basically enhance. So it will allow a value between 0 to 1. It's available now.
Yeah. Okay. Regarding hyperelastic, I'm not sure what was presented over there, but let me read it out. Hyperelastic model, why do we use tensile test data twice?
We are not really very sure about the questions.
Yeah,
But
I
generally,
Yeah, we can take it offline, I think.
Yeah, it take it tensile test data and compressive test data differently.
Yeah. Yeah. So
I would request the questioner to write to us maybe if he has any specific
yeah,
about that.
and I'm not sure if it is pertaining to some slides that you have or it's a general question you ask. So yeah, please write to us. We'll get to it and give you an answer. No problem. Any improvements or integration with PTC Creo software?
No, not as such. So PTC Creo to Abaqus is basically a one-directional connection. So there is no such improvement happen in the integration of.
Yeah.
Yeah.
And one more question: does the AM plugin cost additional? So Shri and Subhadip, you can comment. But the AM plugin in Simulia, if you get it in Abaqus, it's part of your Abaqus license. It is just a plugin that will be available. If you are thinking of a 3D experience platform, which I strongly encourage all of you to at least take a look at it, and we can help you with that as the evaluation and what information available there. That one, it's a role based and apps based, so you have to have that separately for the AM. But if you're talking about AM as just a simulation plugin in Abaqus, it should be included in your licensing, Abaqus licensing. So, but as I said, I strongly encourage you to also look at the 3D experience. There are a lot of things happening there. It's a more holistic solution, so maybe you might find it very useful with your current workflow improvements. Okay, is there any other question? Done? No more questions, right? Okay, so I think we have kind of catered to all the questions, and if there is something more, let us know. Otherwise, we thank you all for your participation and interest, and sitting there for the long webinar is kind of one of the longest one with too many information. So take your time, and it's not the end of the day. So if you have any question in future, do let us know. And as we said, we also provide consulting services and software sales, and we are very actively engaged with your client. So if you have any question regarding that sales or the consulting services, please let us know. We'll be more than happy to talk. Thank you. You all have a nice rest of the day and happy rest of the week. Thank you.
Thank you.
Thank you, Sri. Thanks, Subhadip.
Thank you.
Thank you.